As we all know that an Angular is a front-end application, which means your Angular app will be running in a web browser. Welcome to CodeWithSrini. In this video, we're going to look into Angular 6 HTTP request making REST calls with HTTP. In modern web applications, we definitely need a bunch of HTTP services on the server, and we make use of the services to fetch or save data to it. In this video, I'm going to show you how to build a fake HTTP service, and we're going to use a backend for our service. Okay, so to do that, let's head over to json placeholder typecode.com. It's right over here. So when you scroll down, you can see various HTTP services such as posts, comments, albums, photos, to-dos, and users. So now let's go to to-do. In to-do, you will see a bunch of objects here as an array. It's an array of objects which have properties like user ID, title, and completed as false. We don't need any of this. We just need the title and user ID. So we're going to use this URL to make a call, service call, and then fetch these information and display that into our Angular application. Getting data from server. Let's go ahead and write a code to get data from server, especially those are the JSON ones that we have seen in the JSON type code. So we'll be getting those into our Angular application. Right, so in our VS Code, I'm going to create a new component called to-do. So it's going to be ng generate C for component and to-do. So this will create a bunch of files, which is component, CSS, HTML, and specs. So let's add this component in our to-do component in our app component. So before going further, let me go to the TS file and then remove this bit. So I'm gonna have our custom HTML tag, so it'll be, oh, it's already there. So okay, so I think I didn't restart the server, so let's do ng serve to do work. So it's fine. Now we created a component. Now the first step in consuming an HTTP service is we need to include HTTP module. So let's go ahead and let's go to our app module first. Right, we're already in app module. And then here in the imports array, as you've seen here, next after the browsers module, we need to include our HTTP client module. So, and we need to import the client module in the top of our class. So that will be from @angular/common/HTTP. The errors are gone now. So we include, the first step is including HTTP client module in our Angular application. So all the classes that we are working with HTTP are encapsulated in this module. Now let's go to the to-do component. Right, in the to-do component, first thing first, let's go ahead and declare a variable called to-dos with any as our data type. And then in the constructor, let's go ahead and add our HTTP service like HTTP, and it's gonna be HTTP client. Right, so HTTP client for the common Angular common HTTP, that's the one we need to include. Once we do that, if you notice, TypeScript VS Code automatically added our import statement, import class for the HTTP client in at the top of the document. So now let's go ahead and do a simple fetch. Okay, so you will notice the HTTP class is defined on top. Once again, it does not matter if you're going to send the data or get the data. We're going to use this HTTP class or send HTTP request to backend. Now, before going further, let's check our browser for any further errors. Looks like, to doubly sure, we'll just do this. Check the console. Everything looks fine and everything works. So let's go ahead with getting the data. So now in our component, I'm going to use this HTTP client to send a HTTP request to the server. So that's going to be like http.get. This get method, if you notice, it will be returning an observable as a return object. So it'll be returning an observable, and you can subscribe to these observables. So the other thing that I want to include is the URL. So private URL equals, so let me go ahead and copy our to-do. Okay, so that's pretty much done. Now look at the return type of this get method. So you might notice that it is returning an observable here. So observables are used to work with asynchronous non-blocking operation. So here we're gonna go over the network to fetch a data which is an asynchronous operation. What if the data is not available immediately, and expect that there is going to be some sort of a delay, maybe a few milliseconds to half a second. During this, we don't want our main thread to be blocked. So we use observables, and when the response is ready, we will be notified with the subscription. Promises also does the same with some differences with observables. But let's focus only on observables. Now this observable has a method called subscribe. Using this, we can chain a method here, and with this we are basically subscribing to this observable. So here I can pass an arrow function and response to a code block. So it'll be like subscribe and response this to a code block. As a matter of fact, let's just do a console log to check our response object. I'm gonna copy and paste here. So let's open up our console. Yes, you can see the array of objects that's returned from the JSON placeholder through our HTTP request. Okay, now instead of logging this JSON to console, we can set this to an array. So for example, we already declared an array over here which is todos, so it will be this dot todos equals response. Right, so that's pretty much all right. And now what we can do is, let's go over to our template and display our list of todos. So to do that, let's get rid of this. Now we're gonna iterate our todo which we got over our JSON placeholder. So let's do one thing. Let's create a UL class with a UL element with a bootstrap class which is a list group, and then inside that we'll be having an li with a list item. Remember, UL and li are HTML elements, and class belongs to the class list group and class list item belongs to bootstrap. So do not worry much about these classes. The class instructions and definitions are readily available in bootstrap. You got plenty of documentation about these stylings. You can get over to bootstrap to get more information about the stylings. For now, to make things look a bit pretty, I'm just using this bare minimum styling. So now in the li, let me do some indentation to make the code look a bit pretty. I'm gonna do ng for, which is a directive to iterate, and let this to todo of todos. So this todos is nothing but the one we have seen here, the one which is assigned to this field, right? So next thing is, using the interpolation, let's display our todo.title. So this todo.title, the dot notation comes from here. So this will be the one that will be displayed in our template. So once that's done, bingo, we have our to-do list. Hang on a second, we don't have a bootstrap styling here. I'm not sure what went wrong. So let's go to the style CSS. It's available here. All right, let's ignore that for a while. Okay, I made a mistake. It should be list group item. It should be that. Yes. All right. So we got it right. So we just did a bare minimum get request using HttpKit. So in our constructor, we have this get request, and we did a subscribe to that, and then we are displaying this response into our HTML template. So this is pretty much done. Now the next thing is creating a post. Now to create a post, let's head over to our template again. Now in the template, on top of our UL element, let's add an input element. Okay, so it should be input type of text, and it should have a class of form control. These are all bootstrap classes, so please don't worry much about that. Class form controls. Now we need to handle this event. So basically, let's go to the UI. We will be having an input element. So once we type it and once we enter it, there should be an event triggered. To do that, we need to apply an event to our element, which is key up dot enter equals, let's have a method which is called as create data. So once you do that, your create data method, once you give enter, your create data method will be called, which will be inside the component TS. Okay, so we want to call this, okay, we need to pass the value of this text field to this method. To do that, we can create a template variable, which is can be anything, but for me I will give it as to do, and then this template variable need to be passed into our create data. So what we will do is we'll do a quick checkup. Let's create it here, which is a create data and then to do. Let's console that and see. Right, so test. You see here we are getting the input element as a console log for the to do. We can use this to do and the value to get some information what we are typing in. So let's do test and test. Okay, so this is how we can get value from our template. Now the class is form control, it is not controls. So now we got the styling properly done. So this is it, this is the template part. Now let's go ahead and create our post method. Here we're going to use the HTTP class again. Now in the constructor, let's declare it as a private keyword. So let's make this as a field in a class. So it's going to be private. So this HTTP will be available to our subsequent functions that we're gonna define. So this HTTP will become this, and now we have few different types of HTTP request. Each request has a verb and a definition. We use HTTP get to get data, post to create a data, and HTTP put to update a data, and delete to delete the data. Before that, let's declare our HTTP URL in a variable. So which is, we already done that, so let's not worry about that. When calling the HTTP post for an URL, the post expects a JSON object that passed as an argument. So I'm going to create a JSON object which will be let data. That's the one that's going to be passed as a JSON object for the post, and I'm going to do a title of todo.value, which we have seen earlier. For now, for a simple example like this, we are sending just one property. In a more realistic application, we may have to send multiple properties. Now the next thing is we're going to create an HTTP post. So this .http.post, and this is going to be a URL, and the data that we created will be used. Again, we're gonna use the subscribe method. The subscribe will be having a response which is kind of similar to the one we have seen for the get data, which opens up a code block, and then console log our response. Right, so far this is primarily fair enough. We can add this to our, okay, let's first check the round trip here. Now CodeWithSrini. So what happens? Yeah, it's working. So we are getting the response from the JSON type code that we have sent. Now let's go ahead and check our network. If you notice the headers, the data that we have sent is titled. So yeah, this is the title that we have sent, and it is sent properly. And then it made a post request as well as the URL that we passed on and the preview that we got. So this is pretty much about the post information that we have we sent. And the next bit is, let's minimize this for a while. We can finally we can add this to our to-dos array, so we can see it in on our view. We can use the push method like this dot todos dot push and response. Now we can do this, but by doing this, it will push our entry to the end of the list. Instead, if we use splice method, it will show at the beginning of the list. That's what we need. So we don't want this push method. So let's go ahead and use the splice method. This dot todos dot splice and the start of an array, which is the beginning of an array, and we don't need to delete anything in between, and the data that needs to be pushed in. So once you do that, now let's check. Cool, we got it. And the next thing is we still have the data here, so we need to remove that. So once we receive the data, we need to go to the to do and set our value to none. Check again. Cool, it's working fine as expected. So this is all about posting the data to the server and processing the data once we get the information from the server. So we have seen the subscribe method and we have seen the HTTP post. This works same for the put and delete verbs. Okay. All right, we missed one finer detail in this. So usually the data that we send and the data that we're going to get back will be of same snapshot. Okay, which means if you look at the console of what we send, like for example, if I am going to give Srini, so if you look at the console, you are getting an ID as well as the title. So typically in the real world aspect, the data that we are sending and the data we are receiving back must kind of have this similar kind of snapshot. So in the data object, we can use data.id and response.id to fit that in before we pushing this into our to-dos array. But hang on a second, you will be instantly noticing one thing here, which is TypeScript is complaining about the property does not exist. So we can go ahead and add our ID of let's say 0 for now, which will wipe out the error for now. But no, we don't want to do this. Instead, we will be using our square bracket notation to solve this issue. Now, instead of what we have done is, instead of accessing, we are using our square bracket notation to set our ID. Okay, so pretty much vague, but once you start building your application, in a large scale, you will be knowing why this is much more important. If you notice, we are calling the get method inside our constructor, which is very wrong in every way. As a best practice, constructors should be small and lightweight. So we shouldn't perform expensive operations like sending an HTTP service to the backend. You might ask, what's an alternative? Well, components in Angular have lifecycle hooks. They are special methods, and Angular will automatically call these methods at specific times. For example, when Angular creates a component, renders it, or destroys it, these are the examples of lifecycle hooks. Angular will call specific methods during these events. When we create a component through CLI, Angular by default creates an interface called OnInit and creates a method called ngOnInit, which you can see right over here. Because we created using ngCLI, the ngOnInit and the implements in OnInit is already defined for us. Now there are other lifecycle hooks in Angular. They are OnInit, onChanges, doCheck, and so on. So first thing first, what we're going to do is, let's cut this code from our constructor and keep our constructor less busy and move this to ngOnInit. Okay, all right, pretty much the same code. So we're gonna have our display over here. So Yes, it's there. And then yeah, this is pretty much what we wanted. So we just moved our code from constructor to a lifecycle hook called OnInit. Okay, there is another immediate problem we have. So far I have been showing you ways to call an HTTP client, but I've been showing you to call from the component, which is actually wrong. There is a problem with this approach. It clearly violates the separation of concerns. Angular doesn't force you to follow the modularity approach, but on the long run and in a more complex application, moving the HTTP endpoints and HTTP services to a separate class will make the code more modular and clearer. Okay, so what I would suggest is we're gonna move this code, not the entire code, but we're gonna move some of the implementation into a separate service. Okay, so in future you can reorganize. For example, if there is going to be another service, HTTP service for calling the user component and user services, you will be using a separate set of components and services for that. So for the sake of modularity, this will be pretty much helpful. Now what we're going to do is we're going to create a service. So it's going to be ng g, which is generate service, and we're going to call it as todo service for now. Okay, once that's done, our todo service, we have two files, spec and service.ts, which is right on the app directory, right? So first thing first, what I'm gonna do, now if you notice, we have our todo services, which is listed right under the app directory. Now first thing first, I'm gonna reorganize this code a little bit. Okay, so I'm gonna create a new folder called services and then move these two inside move. So I just moved these newly created services inside the services directory. So next thing is, let's go ahead and add this into our app module as a provider. We go here and then call it as todo service. Hang on a second. Yep. So once you add that, your service will be inside the provider, and then your todo service import statement will be automatically added by Visual Studio Code. So that's done. The next thing is, let's open our todo service. All right, so it has an injectable and then our class name. What I'm going to do is copy this URL. I'm going to cut this URL and instantly you will get an error. Let's see the console. Yes, and move this to our todo service. Right, and then now in our constructor we need to inject our HTTP client. So private HTTP and then HTTP client, which is a Angular common HTTP. Right, so now let's go to todo component again. Now in the todo component we need to add our services. Let's remove this HTTP implementation, and then we will be using service, and obviously it will be our todo service. Right, so automatically added, and our HTTP client, let's remove that. Oh, we have one more item which we don't need. And then in here, instead of HTTP, it will be HTTP service dot, it should be something else, right? So it should be, let's call it as get, hang on a second, get todo, right? Because this method is not available in the todo services, let's go ahead and create our method called get todo, and we don't need a URL for this because we already defined our URL over here in our services. Now in here, obviously our component will be expecting a return type. So let's start with a return, which is an observable, because the HTTP sends an observable as a return type. So HTTP get and this dot URL, and I think it's pretty much enough. Yeah, so there you are. We just used a separate service, encapsulated our HTTP client inside a service, and then used our component and then rendered and displayed our todo list here. So it's pretty much work. This is separation of concern. Now let's go ahead one step. Okay, do this for create post as well. So what we'll do is we'll do create to do, and then a create to do will accept a post, will accept a data for us. So we'll be having a data, and then let's do return this dot http dot post this dot URL. This is the URL that we're going to send, and then an extra parameter for passing the data to the backend. So that's pretty much it. Now in our create data method implementation, we need to change it to service, and since we are accepting only the data, so the post will change into create to do. Okay, so let's check test create to do. It's working. So far everything is fine. This is pretty much it. We have pretty much covered everything, but we haven't looked into the error handling for now. What if a request fails on the server, or there may be a chance for poor network connection that it may prevent a service call to the backend? You can very well handle this in a component that comes with the subscribe method. If you notice, the second argument in the subscribe method is the error. So if I just go ahead and give it as error and then console.log and error, you will instantly notice the kind of error that we get. Okay. Now immediately there is a problem with this approach. We are clearly violating the separation of concerns here. Typically, a component may have numerous HTTP calls in real world. The code becomes too much noisy and hard to maintain on the long run. So to do that, Angular allows us to make use of catch error method that comes with RxJS. So let's go to the service and do some error handling. I'm going to get rid of this error. So because we are going to handle errors on a global scale. Now, obviously we have a network failure because the URL that we have given here is incorrect. That's why we are getting this error. So let's not worry about that. And let us create a common error handling method. So I'll have a private handle. Oh, why private? Just handle error, and then the type of error that we're gonna have HTTP error response. So the Angular common HTTP contains HTTP error response as well. So in here, I'm gonna alert our error, and then return. What are we going to return? I think we need to return throw. Yes, something like error in HTTP to make it more clear. Okay, so we have our method, and then we need to implement this method. So now in the HTTP GET, in AngularJS we have throw error from RxJS. Now we have certain set of operators like map, catch error, and retry. So before using the catch error, we need to import them from RxJS, right? So already we are using throw error from RxJS. Now we're going to use catch error from RxJS operators. So in our to do, let's chain them with pipe and catch error, which is automatically showing up. Now in this one, we're gonna call the handle error method. So what this will do is, yeah, it works fine. Let me close this. So this is the final implementation of how we're gonna handle the error. But on a broader sense, handling HTTP error is a vast subject. There are different types of HTTP errors, but for now, I'm just showing you the very bare minimum basic error handling in here. So error handling is typically huge. So this is just a start. Okay, so this is basically all about an HTTP call to the backend and processing the response that we get. In conclusion, we have seen adding HTTP client in app module and creating a separate service for fetching or posting a data, made use of observables, subscribe method, and finally handled error in case of network down or server not available. Thank you for watching. If you like my video, please give it a big thumbs up. Also, if you have any suggestions, do write it down on my comments, and thanks again.